Alright, welcome back to Inorganic Tutors Institute. Today is another episode and we are going to look at some multiple problems in Advanced Calculus 1. Alright, but basically, as I said earlier, our vision is very high to develop a world-class educational institute that integrates STEM and business programs into a unified environment for the modern student. So you know what, I'll come back to structure the course on the channel for your understanding from the very basics to the advanced level. Okay, so let's begin with this particular problem. Okay, basically we are going to solve 20 multiple problems. That is a quiz. All right, so the first problem is they want us to know the right choice of delta, okay, to prove this particular limit. All right, so for you to be able to know the right choice of a particular limit, all right, the right choice of delta to a particular limit, you have to go through series of processes, right? And that is where you have to use epsilon delta definition to be able to understand that, to identify the right delta. Okay, so first of all, so step one, let's write the limit down. Limit as xy approaches 1 and 2 of 3x minus 2y equals -1. All right, so this is the limit that we have been given. All right, so first of all, we have to rewrite the expression. Okay, we have to rewrite the expression 3x minus 2y to be equal to, you know, from the beginning, I always say that f of x minus the limit, right? So f of x here means the function given, right? So we are going back to that same process to write this. So -1 minus into -1, all right? This is the limit. Now, this is equal to 3x minus 2y plus 1. Okay, right. So once we have this, then once we have been able to do this, then the next thing is to rewrite this expression. All right, so we write that as 3x minus 2y plus 1, and that is equal to 3 into bracket x minus 1 minus 2 into bracket y minus 2. Right, this expression is the same as this. So let's try to expand it. To expand, you have 3x minus 3 minus 2y plus 4. So this, you have +1, then you have your number back. So you express this expression as this, right? So that is basically what we have to do. We rewrite this expression as that. Now, step 2. Step 2. We have to apply what we call the triangle inequality, right? We have to apply what we call the triangle inequality, where we introduce the less or equal to sign. So, we are going to say that we have 3 into x minus 1 minus 2 into y minus 2 to be less or equal to 3 into 3 times the absolute of x minus 1 minus So because of the absolute sign, this will tend to 2, positive 2 times the absolute of y minus 2. Right? So this expression, when you introduce the inequality sign, you know, this expression, when you introduce the inequality sign, then you're going to have 3 into this, and this will tend to positive because of the inequality sign. All right? Because of the inequality sign that we introduce. So this is less or equal to this. This expression that we have on the right hand side is less or equal to that. Okay, so step 3. Step 3. We have to use the distance formula. That is, so distance condition. Distance condition, that is, if you have x minus 1 all squared, the square root of that, plus y minus 2 all squared to be less than delta, then we can say that x minus 1, all right, absolute of that is less than delta, and then y minus 2, that is absolute of that, will also be less than delta. All right, so once we have been able to express that as this, then we use the distance condition. All right, that is, if you have this, then you can say that x minus 1 is less than delta, and also y minus 2 is less than delta. So if that is true, then we can say that we have absolute of 3x minus 2y plus 1 to be less or equal to, here we are saying that this should be less than delta, so we are going to have 3 times delta plus 2 times delta. All right, we have stated it over there, so we have 2 times delta. All right, so this expression, we know that we can combine these two expressions. 3 delta plus 2 delta will give us 5 delta. All right, so we are going to have 5 delta. All right, so that is 5 delta. So basically, to make this expression to fit well, or to choose the right surface, it means that we have to say that delta should be equal to a value that can be able to, take this thing off, right? So we say that, remember, this place, it has to be less than epsilon, right? So we are going to say that 5 delta should be less than epsilon, right? So we divide here by 5, divide here by 5, then we have delta to be less than epsilon over 5. So this should be the right choice for delta in this particular limit. Not done, we have to choose a minimum value for delta and then this value, so that we can be able to have this limit. All right, so now we have to choose a minimum of 1 and also epsilon over 5 and also epsilon over 5. So we can say that delta is equal to a minimum of 1 and then epsilon over 5. So we have delta to be equal to a minimum of 1 and then epsilon over 5. So that is basically the right choice for delta in this particular limit problem. I believe you enjoyed the lesson. Now give me some short break. I'll be back with question number 2. Alright, welcome back from the short break. I believe that you have been able to go through the very first problem and you're good with it. Right, now let's look at question number 2. We have been given this particular function, alright, f of x and y, 2 variables, okay, multiple variables, x and y. So the function is e to the power 4x minus 3y times cos into x squared plus y cubed. Now, they want us to compute the partial derivative of the function with respect to x and then evaluate it at the point q of -1 and 2. So, what are we going to do? Looking at the function, 2 variables, it means that we are going to do partial derivative as said in the question. And the question is 2 functions combined. That is the product of 2 functions. So this should sense some idea that you are going to use what we call the product rule. That is why I said that watch out the link below the video at the description and get the tricks for product, quotient, and those basic differentiation rules. Alright, so let's begin with this particular question 2. So this particular question 2 is right. Now we want to find the first derivative of this particular function with respect to x. Then when we are done, we evaluate it at -1 and 2. So what are we going to use? We are going to use the product rule here. Now remember, the product rule says that if you want to differentiate a function, all right, we use it basically when we have 2 functions that are stacked together. All right. So we always let one function represent u and then the other function represents v. All right, so the basic idea is that you use the first function to represent u and the second function to represent what? V. So if you have uv, that is 2 functions multiplying, and you want to differentiate, then the first thing you do is that you differentiate the first function, maintain the second function, plus maintain the first function, then you differentiate the second function as well. So this is the condition. So if you know this condition, then you are done with this particular problem. So let's go. Let's u equals e to the power 4x minus 3y, and then v equals cos into x squared plus y cubed. All right, so looking at the formula, what do we need? We need u prime and v prime. So from u, we know that our u prime means the derivative of u, the first derivative of u. But now the question says that with respect to x, so differentiate this particular function with respect to x means that we are going to maintain the function itself, right? You know that exponential function, if you are differentiating, you maintain the function itself, then you differentiate with respect to the variable that you are interested in. So we differentiate with respect to x, so with respect to x here means 4x. So we differentiate 4x, you have what? 4. So we differentiate that, we're going to come and multiply it with the function. So we are done, right? Then the v prime means we are going to differentiate cos into x squared plus y cubed with respect to what? X. First of all, we are going to, you know that we are going to use implicit differentiation, right? Implicit differentiation. So we differentiate cos, and then we have negative sign. Remember this trick differentiation or trig derivatives. If you differentiate cos, you have negative sign. So we have negative, all right, negative sign. Then we write the function, all right. Then we come back to the inner function, all right. So the inner function here is x squared plus y cubed. Now we are differentiating with respect to x. So we differentiate x squared, you have what? 2x. So you multiply it by the function, right? So we have minus 2x sine into x squared plus y cubed. So applying the formula, then we have our first derivative with respect to x of the function x and y to be equal to, we looking at the formula, u prime is here. So we have 4 e to the power 4x minus 3y. Then the v is cos into x squared plus y cubed, right? Plus the second part will be u, then v prime. So this is the u, and then this is the v. So either way, they are all multiplying. So we bring the negative first, minus 2x sine into x squared plus y cubed times the u, which is e to the power 4x minus 3y. All right, so we simplified, we arranged this well. We arrange this well, and then we have 4 e to the power 4x minus 3y times cos into x squared plus y cubed minus 2x e to the power x e to the power 4x minus 3y times sine into x squared plus y cubed. So this is the first derivative of the function f with respect to what? X. Now, at the point q of -1 and 2, it means that x is -1 and y is +2. So this means that x is -1, y is +2. So we substitute it inside. Fs of -1 and 2 will be equal to 4 e to the power 4 into -1 minus 3 into 2, right? Times cos into -1 squared plus 2 cubed minus 2x -1 sine into -1 squared plus 2 cubed times e to the power 4 into -1 minus 3 into what? 2. So we just have to simplify this, and then we have our value. So we have 4 e to the power -4 plus 6 minus 3 times 2, we have -6, right? Times cos into -1 squared is 1 plus 2 cubed is 8. This will be positive 2 sine into -1 squared is 1 plus 8 times e to the power -4 minus 6, right? So when you break this down, you have 4 e to the power minus 10 cos into 9 plus 2 sine into 9 e to the power minus 10. All right, so this we can basically factor e to the power minus 10 out. So when we do that, we are going to have 4. We are going to have e to the power minus 10 out. 4 times cos 9 plus 2 sine 9. Right? So this is what you are going to have. So if you simplify this, you are going to have, if you simplify this, yes, so if you simplify this, this is what you are going to have. And I think we can leave our answer here. Yes, we can leave our answer here, because if you try to punch this, you are going to have decimals. All right, so let's leave our answer here. So basically our answer is e to the power minus 10 into brackets 4 cos 9 plus 2 sine into 9. So that will be our answer. So that will be our answer for the question number 2. So we have e to the power minus 10, big brackets, 4 cos 9 plus 2 sine into 9, close brackets. So this is our answer to this particular problem. Very, very easy. You know, the trick is, remember your trig, derivatives, remember your basic product and differentiation rules. That is all about mathematics. So this is the solution to this question number 2. Now give me some short break. I'll be back with question number 3. Welcome back from the short break. I believe that you have been able to go through the problem number 2 and you are good with it. All right. So with problem number 3, we have been given this function, all right? And we want to know the domain and the range, all right? So how do you find the domain and range of a particular given function? So we have g of x and y equals cos into xy, right? Now, we want the range and the domain, right? So we start with the domain. So for the domain, you know that for the domain, these variables we have here, x and y, which are the inner function of the cos, right, are defined for all real numbers. You know that because it's a linear function and it's not a fraction, right? It's not a rational function, right? So it's defined for all real numbers. So xy is defined for all real numbers. Sy is defined for all real numbers, right? And then we know that cos is also defined because it's a linear function. It's also defined for all real numbers, right? So basically, we can say that the domain of this particular function is the domain belongs to all real numbers, right? So the domain of J is equal to all real numbers. You know, we are dealing with x and y, so it's going to be r squared. So all real numbers that belongs to x and y. I believe you are good with it. Now let's look at the range. So with the range, remember, for you to get the range of a particular function, especially functions like cos and sine, you know that cos and sine, they lie within a given boundary, right? They lie within a given boundary, that is within -1 and +1, right? So always know that sine and cos, they are bounded within +1 and -1, right? So the range for this function is going to be -1 less or equal to cos of the function less or equal to 1. All right, so that is the range for this particular function. So we can say that the range of J is equal to -1 and +1 inclusive. Because of this, less or equal to, so it will be inclusive. Okay, so in all, we say that the domain is equal to x, y, that belongs to r squared, okay, such that x belongs to r, y belongs to r, okay. Then the range of the function J is equal to -1 and +1. Okay, so the solution to this particular function is the domain is for all real numbers. The domain belongs to all real numbers, that is r squared, because of the two variables. If it were to be only one variable, it would be r. Then the range, because it is cos, right, is going to be within -1 and +1. So -1 and +1 inclusive. So that is the solution for question number 3. Now, let's look at question number 4. We are to calculate F223 of x, y, and z. And they want us to know, or they want us to tell the right formula to be able to evaluate this. Okay? So first of all, what you have to know is that if you see F223, it symbolizes something, right? So F223 means that F2 means, first F2 means derivative with respect to y. Derivative with respect to y. Second F2 also means derivative with respect to y, right? So the last one, F3, means derivative with respect to z. Okay, so the right formula for this particular thing given is going to be, the right formula is going to be F223 will be equal to partial derivative of a function, right, with respect to z. Okay, partial derivative of a function with respect to z into brackets partial derivative of a function with respect to y times partial derivative of a function with respect to y again. So the right arrangement, you keep this, you differentiate this, you differentiate this. When you are done, you come and differentiate this. All right, so the right formula is that. So F223 means partial derivative of z times partial derivative of what? Y times partial derivative of what? Y. So that is the right formula to this particular term. Note, if you see f2 is the same as partial derivative with respect to y. If you see f2 is the same as partial derivative with respect to y. If you see f3 means partial derivative with respect to what? Z. So that is basically what you have to know to be able to answer questions of this nature. Right. Given some short break, I'll be back with question number 5. All right. Welcome back from the short break. I believe that you have been able to... All right. Welcome back from the short break. I believe that you have been able to go through the question number 3 and question number 4, and you are well equipped. Now, with question number 5 and question number 6, we are going to handle that one too perfectly. With question number 5, what you need to know is your derivative tricks. Remember how to derivative or how to find the derivative of tan inverse. Okay, so now, first of all, you want the derivative of tan inverse with respect to x. So, step 1. Let's rewrite the z, tan inverse of y over x, to be equal to tan inverse of y times x to the power minus 1. You know they are all the same. Now, we want to differentiate this with respect to x. So, we have the z that is z with respect to the x, and that is equal to, we differentiate this, right? So that will be negative. So we're going to have negative of the constant. Then this will descend, right? So we're going to have minus y over y squared plus what? X squared, right? So this is the derivative with respect to x. Now, the derivative with respect to y, derivative with respect to y will be equal to the same approach, but then with respect to y at this point. So with respect to y, we are going to keep x, then we differentiate with respect to what? Y. So with that, we are going to have, x over, because when you differentiate this, you're going to have, so x over x squared plus y squared. Right. So with respect to y, we have x over x squared plus y squared. You know why we had positive here? Because the y is at the numerator. Because the x was at the denominator, we raised it and there was a negative. That is why we had negative affecting this. But because the y is at the numerator, we had positive. Now, this is our derivatives. We want to evaluate it at -1 and +1. So we have at -1 and +1. On the first one, we are going to have the z with respect to x will be equal to negative into bracket. This means that x is -1 and y is what? +1. So we have negative into brackets 1 all over 1 squared plus 1 squared, and that will be equal to -1 over what? 1 plus 1. All right, and that is equal to basically -half, which is 0.5, -0.5. The same thing applies to this, but this will be what? Positive. So the z with respect to y will be 1 over 1 plus 1, and that will be equal to 1 over what? 2. So we have positive 0.5 for the one with respect to y. So our answers are going to be, let me come back here. Okay, this is positive, right? And the x value is negative. So it means that we are going to have negative affecting this, and then we have negative here, right? So all the results are giving us negative 0.5, negative 0.5. All right, so our solution is going to be J. They gave us, so we are going to have the Z respect to X to be equal to negative 0.5, comma, and the Z respect to Y equals negative 0.5. So that is our solution to question number 5. That is so interesting and amazing, right? Once you know your derivatives, the tricks to that, nothing in calculus will be difficult for you. Now, with question number 6, right? With question number 6, we want to find the right value or the right choice for delta, right? The right choice for delta, so that we can use the epsilon delta definition to prove this, right? So how are we going to do this? We have to go through the process, okay? But this time we are not going to go through the lengthy process. You just have to use the tricks, and then we are good to go. So with question number 6, step 1, what we have to use is the inequality, right? So let's first write the problem. Limit as sy approaches 0, 0 of sine into x minus y equals what? 0. Once you have 0 as your limit, the problem becomes very easy. You know why? Because you are not going to have any complex expression. Good. So we use the inequality to handle this. Okay, so we know that sine into u, absolute of that, is the same as, or is less or equal to, absolute of what? U. That is the inequality property. Now, once we have this, the next thing we have to do is to insert the right expressions, right? So we have absolute of sine into x minus y less or equal to absolute of x minus y, right? And that is less or equal to what? Absolute of x plus absolute of what? 1. Absolute of x plus absolute of what? Y. So this is all we need to be able to do this, to find the right choice for what? Delta. So in step 2, what you are going to use is the distance to bound absolute of x and then absolute of what? Y. Okay, so we know that absolute of x plus absolute of y must be less or equal to 2 delta, right? This is a delta, this is also delta, right? So absolute of x plus absolute of y must be less or equal to what? 2 delta, right? So to get the right choice for delta, then we have to choose a surface that will clear this. So we have 2 delta to be less than what? Epsilon. So we divide here by 2, divide here by 2. We have delta to be less than epsilon on what? 2. So that is our right choice for this particular problem. All right, so the right choice for delta is epsilon over 2. So epsilon over 2, that is our delta. So our delta is epsilon over 2. Epsilon over 2. That is so amazing, right? That is question number 6. Now let's go back, have some reflection, and come back for question number 7. All right, I'll be right back in no time. All right. Welcome back from the short break. I believe that you have been able to go through problem number 5 and problem number 6, and you are good with it. Right, I'm so glad you are satisfied. Now, let's look at problem number 7. Okay, so with problem number 7, we have been given this function, okay, and we want to find the limit of the function. All right, now with question number 8, we have been given some function and want to evaluate all the first partials and evaluate it at what? And find the exact value at a given point. So let's deal with question number 7 and come back to that. So with 7, what we have to do first is remember the coordinates or the polar coordinates, right? You remember that. So first of all, let's rewrite the problem. F of x and y equals x squared minus y squared divided by x squared plus y squared, right? Now, remember that x and y must not be 0. You know why? If x and y become 0, we have what? Undefined problem. Great. But one can be 0 and other can be non-zero. But never can all be 0. If all becomes 0, we don't have a proper function. Good. So what we are going to use is the polar coordinates, right? So we use the polar coordinates. So using the polar coordinates, we have, so we are going to let x represent, so let x equals r cos theta. Remember this properties, right? And then y equals r sine theta. So these are properties, okay? We have a proof for it, but for now we are not interested in the proof. Okay, so we're going to say that our f will be equal to r squared, or let me write this before, r cos theta all squared minus r sine theta all squared divided by r cos theta squared plus r sine theta squared, right? So when you expand this, you have r squared cos squared theta minus r squared sine squared theta divided by r squared cos theta cos squared theta plus r squared sine squared theta, right? So we have our f to be equal to, r squared is common to these two items, right? So we say that r squared out cos squared theta minus sine squared theta, all right, divided by r squared is common here again, so we take that out and we have cos squared theta plus sine squared theta. So remember your trig identities, or from the trigonometry course, you know that cos squared theta plus sine squared theta produces a result of +1. So we have f to be equal to, so you know that this takes off this, so we have cos squared theta minus sine squared theta divided by, this becomes 1, right? So we have over 1. So we have our f to be cos squared theta minus sine squared theta, okay? And this identity, you know it to be something. When you go to double angles, you know that that will give you certain property, right? So this is basically cos, so we can say that this is equal to cos 2 theta. This is equal to cos 2 theta. So when you go to your trigonometry course, back to your trigonometry course, you know that cos squared theta minus sine squared theta is the same as cos 2 theta. That's the double angles. Now, since this result depends on theta, then we can say that the limit does not exist, because we are seeing that the result we are obtaining is depending on theta. So we cannot say that the limit exists, right? So the best option for us to say is to say that the limit does not exist. That is the only way we can go. So therefore, the limit does not exist. Since the result depends on theta, we say that the limit does not exist. So this particular limit does not exist. That is so brilliant, right? Now, let's move on to the question number 8. So with question number 8, we have been given this function, all right? And we want to find all the first partials given this particular expression. And you know that we have multiple variables, x, y, and z. And it is a rational function. All the first partials of this particular function, and then we'll find the exact value at the given point of 2, 3, and 1. Now, our first one will be what? Fs. Remember, I told you the tricks you need in derivatives or differentiation or in calculus is your derivative tricks and integration tricks. In here, we have a function, we have a rational function, and you want to differentiate, you have to apply the quotient rule. So the quotient rule says that you differentiate the numerator, you maintain the denominator, right? You differentiate the numerator times, you maintain the denominator minus, you maintain the numerator times derivative of the denominator divided by square of what? The denominator. So we are going to apply that. So with Fs, it means that all y and z will be a constant. So we have negative of positive 1, maintain the denominator minus maintain numerator, differentiate denominator respect to what? Z, respect to what? X. So we have y plus what? Z divided by the square of what? The denominator. Then Fy means that we have 1, then maintain the denominator minus maintain the numerator, then differentiate the denominator respect to what? Y. So we have x plus what? Z, right? Divided by the square of what? The denominator. Then last one respect to what? Z. We are going to have negative of the numerator respect to what? Z. So we have 1, then maintain the denominator minus maintain the numerator, differentiate the denominator respect to what? Z. So we have y plus what? X divided by the square of what? The denominator. Because the expression is quite lengthy, that's why I'm writing, denoting d as denominator, n as the numerator. You see, so if you see d, it means the whole of this expression. If you see n, the whole of the numerator. Great. So let's first calculate the y plus z. All right. Y plus z means, remember, we have been given 2, 3, and 1. So x is 2, y is 3, z is what? 1. So y plus z means we have 2 plus what? 3, and that is 2 plus what? 1. 2 plus 1, and that is what? 3. Then we have y plus x, and that will be 2 plus what? 3, and that is what? 5. Then we have x plus z, and that will be 2 plus 1, and that is what? 3 again. Okay, so the next thing we have to calculate is the denominator, which is x y plus yz plus xz. So xy plus yz plus xz, and that will be x is 2, y is 3. So we have 2 into 3 plus 3 into what? 1 plus 2 into what? 1. And that will give us 6 plus 3 plus 2. This will give us 11, right? This will give us 11. So we have 11 here. So now we've obtained all the needed values that we have to what? Use. We have to use. So all we need to do is to substitute, and then we are good to go. Right? So we are going to have here fs, we are going to have negative 1 into the denominator is 11 minus the numerator which is s plus y plus z. S plus y plus z, we didn't calculate that, so x plus y, s plus y plus z will be equal to 2 plus 3 plus 1, and that is what? 6. Right, so we have fs to be equal to 11 minus 6 into 4 divided by 11 squared. So we are going to have minus 13. Yeah, minus 13 divided by what? 11 squared, which is 121. 121. And remember, there is a big minus here, so it's going to be fs equals minus minus, and that is going to be what? Positive 113 over what? 121. Okay, so that is for what? Fs. Now let's look at the fy. Let's look at the fy. So with the fy, you're going to have minus, big minus 1 into the denominator is 11 minus the numerator is 6. 6 into s plus z. S plus z here is 3 divided by this 11 squared. So we are going to have this 11 minus what? 9, right? 11 minus 6 times 3 is 18. 6 times 3 is 18. So we have over 121. And that will be equal to, 11 minus 18 will give you a negative value. Okay? 11 minus 18 will give us negative 7. So we have negative 7 here. So we have fy to be equal to negative into negative 7 divided by what? 121. And that is 7 over what? 121. Then we have our last one to be fz. Fz here is negative, big negative, right? The negative is not affecting only the first expression. It's affecting the whole expression. So we have the denominator is 11 minus the numerator is what? 6. And then our xy or yz is what? 5 divided by 11 squared, and that will give us minus 11 minus what? 6530 divided by 121, and this will give us negative into negative of what? 11 minus 30 is negative 19. So we have negative 19 here divided by 121. So our fz will give us positive 19 over what? 121. Okay, so basically fs is 13 over 121, fy is 7 over 121, and fz is what? 19 over 121. So we say that fs is equal to 13 over 121, comma, fy is equal to 7 over 121, and then fz is equal to 19 over 121. So that is the values for this particular problem. So that is question number 8. Give us some short break. I'll be back with question number 9. All right, welcome back from the short break. I believe that you have been able to grab question number 7 and question number 8 very well. Great. Let's look at question number 9. All right, we have this problem, okay? And what's the question asking us to do? We want to know the domain. He said you want to know the domain. Then the domain is given by, so we have been given this particular expression. So this is an exponential expression. This is a log expression at the denominator, right? Plus some common expression, algebraic expression. So we want to know the domain of this this cumbersome thing at the top there, right? So first of all, what I want you to know is that if you have an exponential term, then basically an exponential term is defined for all real numbers, right? It's defined for all real numbers, that is x and y. So solution, the exponential term e to the power x plus y plus 1 to the power half is defined for all real numbers, or for all real numbers of what? X and y. Step 2, what you have to know again is that you see this logarithmic function here, or log expression. What you know about log properties, or what you rewrite from the beginning of your studies in mathematics, what you have learned about log, one of the key things you learned about log is that any expression or any argument that you find within the logarithmic expression or the logarithmic function, it must be positive, right? So being a positive value means it is greater than what? 0. So the logarithmic expression, step 2, or 2, the logarithmic term, which is this 3 log into 2x minus 2, the expression inside the log must be positive. So we have 2x minus 2 to be what? Greater than 0. And this implies that 2x must be greater than what? 2. So this says that if you divide here by 2, divide here by 2, then it means that x is greater than what? Positive 1. Now, once again, the denominator must not be 0. Okay? The denominator must not be 0. If the denominator becomes 0, then we have the whole expression to be what? Undefined. So 1, all exponential functions are defined for x and y. On this, the exponential function is defined for all x and y. 2, what you have to know about the log expression is that any arguments that you see in logarithmic expression, it must be positive. That is, it must be greater than 0. That condition must be satisfied. 2, looking at this expression, the denominator must not be 0. So, once again, the denominator must not be 0. So, also, the denominator must not be 0. Okay? So, we say that log into 2x minus 2, right? Log into 2x minus 2 must not be what? 0. All right? So, once again, we have 2x minus 2 to be what? Not to be what? Equal to positive 1, right? Because if we have here to be positive 1, if we ask x to be positive 1, then it means that this part is going to be what? 0. And we don't have log of what? 0. Log must begin from 1. So log into 1 will give you what? 0. The same as log ln 1. Ln 1 is what? 0. But the reason is why arguments in log expression must be what? Positive. So it must be greater than what? 0. Greater than 0 means from 1 upward. So we have, this implies that 2x minus 2 must not be equal to 1. So we are going to have x to s not to be equal to 3 on 2, right? So s should not be equal to 3 on 2 from here. Okay, so our final answer is going to be, the polynomial term, which is this 5x squared y, is also defined for all s and y because it is just isolated and it is not a fraction or it is not a rational expression. So this is a polynomial term. So it is also defined for all values of x and y. So the polynomial term is defined for all x and y. Okay, so our domain, that's the domain will be equal to x comma y belonging to r squared. R squared here means we have x and y, that's why we are calling it r squared. Okay, excluding x greater than what? 1, or x should not be equal to what? 3 on 2, or x should not be equal to what? 3 on 2. So this symbol means that we are excluding x to be greater than 1, right? We are excluding x to be greater than 1. All right, so the right answer to this particular problem, the domain is xy belong to what? R squared, such that s is greater than what? 1. Okay, such that s is greater than what? 1, or s should not be equal to what? 3 on 2. So these two solutions, or 1, they are all fine. It's either you see all these two or you see 1. So either this or this, right? So I just combine all for you. So that is question number 9. Now give me some short break. I'll be back with question number 10. All right, welcome back from the short break. I believe that you have been able to digest problem number 9 and you're fine. Now, let's look at the problem number 10. We have been given this limit problem, okay? And we want to calculate the function if s and y is approaching what? 1 and 1, okay? So now, always what you have to know or what you have to put in your mind is that when you have a problem of this sort, and it's a fraction, okay, make sure you try to see if the fraction can be factorized. Let's say the numerator we have here ask yourself, can you factorize this term? If yes, try to do that. Okay? If yes, try to do that and see if there will be some cancellation. So from this expression, we know that the numerator can be factorized, right? The numerator can be factorized to have x minus y times x plus 2y. So the numerator x squared plus xy minus 2y squared can be factorized to have x minus y times x plus 2y. Okay, so the numerator can be factorized to have something of this sort. So once we know that, then the next thing to do is to put it back and then do some cancellations. So we have fs and y to be equal to x minus y times x plus 2y divided by x minus y. All right, so you can see that we have some common terms that can cancel out. Okay, so we cancel this, and then we only have x plus 2y. So now we can see that we have a direct substitution expression, and so we have x plus 2y. Okay, so now we can apply the limit as xy approaches 1 of x plus 2y, and that will be equal to limit as x and y approaches 1 will be equal to 1 plus 2 of 1, and that will be equal to limit of what? 1 plus 2, and that is basically what? 3. So we have 3 here. Okay, so the limit for this particular problem is 3. Okay, very simple. Very, very simple. It's equal to what? 3. So that is the answer for problem number 10. Now let's go and come back for problem number 11. Give me some short time. I'll be back. All right. Welcome back from the short break. So with question number 11, we have been given this limit, all right, and we want to evaluate. Okay, now look at the expression. It is a fraction. Anytime you have a problem like this, try to see if you can factorize. If you cannot factorize, then you go ahead with the next stage. So the next thing we have to do here is to substitute this 0, 0. Once you have a fraction and the limit is 0, 0, s and y is approaching 0, 0, then you know that the expression, when you do direct substitution, you get what? Indeterminate. Great. And once you have indeterminate, then you have the liberty to use the different part approach to check if the limit exists or not. So first of all, we do direct substitution. So when we do direct substitution here, we are going to have 0 here, 0 cubed divided by 0 squared plus what? 0 cubed. So you see we have 0 over 0. And this is what? Indeterminate. So indeterminate gives us the liberty to go and use the different part approach. So what we are going to do is to first use the part 1, where we say that y is equal to 0. Okay, so step 1, let's say, so we are using the different part approach. Okay, so let's say y is equal to what? 0. So if y is 0, then it means that we are going to have limits as xy approaches 0, 0 of s cubed divided by what? X cubed plus what? 0 squared, right? Because we are saying that y is 0. So that is going to give us s cubed over what? S squared. And this will take 2 of this, and we have x here. So this means that x and y approaches 0, 0 of what? X. And that will give us what? 0. So it means when we choose different part approach, we started from what? Where y is equal to what? 0. So when y is equal to 0, the limit give us what? 0. Now let's check for when x is equal to what? 0. So at x is equal to 0, we are going to have limit as x and y approaches 0, 0. And that will be what? 0 cubed divided by what? 0 squared plus y squared. And that will be equal to what? 0 over what? Y squared. And this will be equal to what? 0. Okay? So along y is equal to 0, we had what? 0. And then along s is equal to 0, we had what? 0 as well. So this clearly states, or this clearly proves that the limit exists along, since the different part approach are giving us the same result, we say that the limit exists at 0. So therefore the limit, that is s cubed over x squared plus y squared as sy approaches 0, 0 exists at 0. Exists at 0. That is so brilliant, right? Now you understand the different part approach very well. Before you can use the different part approach, it means you have tried direct substitution and you are getting what? Indeterminate. The indeterminate means you are getting what? 0 over 0. So once you have that, then you have the liberty to use the different part approach. And then the different part approach, if you try y is equal to 0 and you are getting a result, let's say 0 as we have here, and you try s is equal to 0 and you are having what? 0. It means that the same result you obtain for what? Different parts. So it means that the limit exists. But if it's other way around, then the limit does not exist. But in here, we have the limit to exist at what? 0. That is question number 11. Let's go back or come back for question number 12. Give me some short. Okay, so welcome back from the short break. I believe that you have been able to go through question number 11 and you are fine with it. Now, let's look at question number 12, where we are given some points and we want to find the distance between these 2 points. Already we know about the distance between 2 variables, right? I mean the 2 dimension. Now we have been given 3 dimensions, so we just have to stretch the formula for the 2 dimension, then we have the 3 dimension formula. So what we are going to do here is to just stretch the formula for the 2 dimension. Okay, so in here, you know the formula for 2 dimension to be square root of x minus x1 squared plus y minus y1 squared, right? Now 3 dimension, which is x, y, and z, will be equal to square root of x minus x1 squared plus y minus y1 squared plus z minus z1 squared. All right, so that is for the 3 dimension. So we are going to apply that to this particular problem. So in here, this is s1, this is y1, this is z1, this is x2, or which we call the x, and then we have y and z. Okay, so we have our distance between A and B to be equal to square root of x is 9 minus x1 is 2, all squared, plus y is 7 minus y1 is 5 plus z is 12 minus z1 is 18, right? So we have square root of 9 minus 2 is 2, right? 9 minus 2 is 7, so we have 7 squared, plus 7 minus 5 is 2, so we have 2 squared, plus 12 minus 18 is basically 6, right? So we have 6 squared, right? So we have square root of 7 squared is 49, plus 2 squared is 4, plus 6 squared is 36. So in all, we are going to have square root of 89, square root of 89, and square root of 89, square root of 89 is approximately 9.434, 9.434. So we have 9.434. Okay, mathematicians will just leave it this way, but physicians or physics students will just add units because we don't know the actual unit, whether centimeters squared or something, whatever it is. But we have to add units, right? So we say that the distance between A and B is equal to 9.434 units. 9.434 units. And that is for question number 12. Now, let's look at question number 13. Question number 13 has given us this expression, okay? Square root of a minus s squared minus y squared. And they want us to determine the domain of the function, how we can describe the domain of the function given, right? So first of all, we have to write the function f is equal to square root of a minus squared minus y squared. All right, so once we have been able to write that, the next thing we have to do is to take, we have to consider the condition for the square, right? So we are going to square, right? We square, then we say that we have a minus s squared plus y squared, right? A minus s squared minus y squared, and that should be greater or equal to what? 0. So we have a minus y squared minus that will be greater or equal to what? 0. So in here, so this is what? The condition for square roots, all right? The condition for square root. So when we take this here and then we maintain this, it means that the sign is going to change. So you have, let's say, you are going to have x squared plus y squared less or equal to what? A. So this is the expression that we have at the moment. So how do we describe this, right? How do we describe this? So this is basically representing a radius, all right? This is basically representing a closed disk, okay? A closed disk that is centered at the origin with radius square root of what? A. Because if you take, remember, the original condition is s squared plus y squared plus what? A squared. So it means that this will be what? A squared, right? Okay, so because these things are like this, that means if you take square root on this side, you are going to what? You have square root of a here. So we have square root of a as our radius, right? So the radius here is square root of a. So the best way we can describe this is to say that this is what? This is basically representing a closed disk, all right? A closed disk centered at the origin with radius square root of what? A. Centered at the origin with radius square root of A. So this represents a closed disk, right? Centered at the origin okay, centered at the origin with radius square root of what? A. So that is the best way we can describe this function, the domain of this function. Okay, that is the best way we can describe the domain of this function. And that is question number 13. Give me some short break. I'll be back with question number 14. All right, welcome back from the short break. I believe that you have been able to go through problem number 12 and problem number 13, and you are so satisfied. Great. Now let's look at problem number 14, where we have been given this expression, the cube root of s squared plus y cube plus y cube, all right, times exponential function to the power sine into s squared y. Now, the first thing you want to do is you want to find the derivative of the function with respect to what? X. And then evaluate it at what? 1, 0. Okay, so this is all about differentiation. Okay, this is all about differentiation. But the only thing that will make the work a little bit tough is the expression given, right? Sometimes students, we see the cumbersome of the expression and it scares us. But most times, the big expressions are the easiest problems you can have, right? Sometimes you see a very small problem and the understanding behind it is not something small. But this is going to be very, very easy for us. Okay, so we start. F of x and y is equal to cube root of s cubed plus y cubed times e to the power sine into x squared y. All right. Now, we want to find the first derivative of this particular expression with respect to what? X. So first of all, what we have to do, right, is to identify the structure. Is this structure very easy to deal with, or is this structure going to go with the product rule or whatever? Okay. Now, I want you to know that this will go with the product rule because we have two expressions that are stacked together, right? So we are going to use the product rule, and the product rule says that if you have a function and want to differentiate, you have two functions that are stacked together and you want to differentiate two functions that are stacked together like this, and you want to differentiate, then first, okay, differentiate the first function, then maintain the second function, plus maintain the first function, differentiate the second function. Right, so we are going to use the same knowledge in here to deal with this particular problem. So we let our first function represent u, all right, which is cube root of s cubed plus y cubed, and that is equal to, you know, this can be expressed as s cubed plus y cubed all to the power 1 over 3. And then, so the first derivative of this expression with respect to x will give us, so that is the u prime. That will give us, we drop this, right? We drop that, then we write this again. Then we differentiate, or we reduce this one by what? 1. So reduce the power what? By 1. So that is the power rule. So 1 over 3 minus 1 is basically 1 over 3 minus 1 is basically 2 over negative 2 over 3, right? So we have negative 2 over 3. Then we differentiate the function inside. So that is the implicit differentiation. So we differentiate the function inside with respect to what? X. And that is going to give us 3x squared. Okay? So we have u prime to be equal to, you know, because this is negative 2 over 3, we can bring it down. So to have 3 x squared divided by 3 into brackets x cubed plus y cubed all to the power 2 and 3. And you know that this will take up this. So we have u prime to be equal to x squared divided by x cubed plus y cubed all to the power 2 and 3. Right, great. So once we have the u prime, then the second function represents our v, and that is e to the power sine into x squared y. Okay, so for us to apply the product rule properly, we have to also differentiate this to find the what? The v prime. So the v prime will be equal to, differentiating this means you have to maintain the function itself, then you differentiate the function on top with respect to x. Now remember, if you differentiate sine, what do you have? Derivative of sine is basically cos, right? So we have cos into the function, then we differentiate the inner function using the implicit differentiation, and that will give us, with respect to x, so we have 2xy. Okay, so that is what we are going to have for the v prime. So in all, we have v prime to be equal to 2xy cos into brackets x squared y e to the power sine into x squared y. Okay, so this is our v prime, and this is our u prime. Okay, and we have our u and we have our what? V. So applying the product rule here will be very, very easy for us. So our fs will be equal to, we said differentiate the first function, maintain the second function, plus maintain the first, differentiate the second. And then, so our u prime here is s squared divided by s cubed plus y cubed to the power 2 and 3 times, maintain the second function, which is the e to the power sine to the power s squared what? Y, s squared y. So we have that to be e to the power sine into s squared y plus the u. We have u here to be s cubed plus y cubed to the power 1 and 3, all right, times derivative of the second function, which is the v prime. So we have 2 sy cos into x squared y e to the power sine into x squared y. All right, so this we can easily factorize the exponential term out, because we have this here, we have this here. We can factor that out to have a simple expression. So when we do that, then we are going to have fs to be equal to e to the power sine into x squared y into brackets x squared divided by s squared divided by s cubed plus y cubed to the power 2 and 3 plus 2xy cos into bracket s squared y. And that is the first derivative to this particular function. Now, let's evaluate it at the given points, which is 1 and 0. This means that x is 1, y is what? 0. So we have x is 1, y is what? 0. Okay, so fs of 1 and 0 will give us, when you put 1 here, it means you have what? Sine 1 times what? 0. And sine 0 is what? 0. So we have e to the power what? 0. E to the power 0 is what? 1. Right? So we have 1 here. Into brackets, we have s squared, and s is 1. So we have 1 divided by 1 plus 0 to the power 2 on 3 plus 2 into 1 times 0 cos into 0, right? Cos 0, remember that cos 0 is 1, but because of this 0 here, this part all go to what? 0. And then this part as well, we are going to have okay, so we are going to have our final answer to be fs of 1 and 0 to be equal to 1 into, this is 1 over 1 to the power any number is what? 1 plus 0. This whole thing will give us what? 0. So we have this. So it means we have 1 into what? 1. And that is basically what? 1. So that is so interesting and fantastic. I told you earlier that if you have a cumbersome expression, the end product is very, very easy. All right? So this is the first derivative. We had this. And then when we evaluated it at 1 and 0, we had what? The result to be 1. So interesting. So interesting. So that is for question number 14. Give me some short break. I'll be back with question number 15. All right. Welcome back from the short break. I believe you have been able to digest question number 14 and you're good with it. Now, we are coming to question number 15 and question number 16. Right? So with question number 15, we have been given this definition. All right? And we want to know the function, what the function is, whether it is continuous, uniformly continuous, or something. So, given epsilon greater than 0, there is this delta this greater than 0 such that f of x1, y1 minus f of x2, y2 less than epsilon. Whenever x1 and y1 and x2, y2 is the domain of f and this distance condition is less than delta, then the function is. So in here, very simple problem. All you need to say is that the function is continuous, right? The function is continuous at x1, y1, right? So, the reason why we are saying the function is continuous is that we can see that we have been given the function, or delta is not depending on epsilon alone. We see we have x1, y1, x2, y2. So the function has been defined. So once the function is defined, then we say it is continuous. But it is continuous on what variable? So it is continuous on x1, y1, right? It is continuous on x1, y1. So we say that given, so solution, given all values that depends on epsilon that is greater than 0, there is this delta that is also depending, that there exists delta depending on what? That is greater than 0, right? Such that f of x1, y1 minus f of x2, y2, absolute of that is less than epsilon, right? Whenever this condition is met, right? Whenever this condition is met, the distance condition, right? So whenever square root of s1 minus s2 plus y1 minus y2 all squared is less than what? Delta. Then this is basically exactly the definition of continuity at a given point, right? So this is exactly the definition. If you see this, it's just telling you that this is a definition for continuity at a given point. But now the given point is what? X1, Y1. So at the given points, so this is defining the continuity at x1, y1. So the function is continuous at x1, y1. So there's a continuity function. So the function is continuous as x1, y1. So that is for question number 15. Now, question number 16, we have been given some series of options and we want to know which of the options is wrong using limit definitions. So when you look through, you realize that the wrong definition is when you have f of x, y, and z plus what? Ln z plus h3 minus the function itself, the original function, divided by what? H2. Then that definition is wrong. You know why? Let's look at the definitions. If the correct definitions, you have fs, okay? If you have fs, then this increment in x is divided by h1. So if you have fs, first derivative with respect to x, then this increment, I want you to know this increment in x you divide it by what? H1. Then when you have fy, then increment in y, you have to divide by h2. Then if you have fz, increment in z, you have to divide by h3, right? So if you look at the options given and you know these definitions, then quickly you have to know that some particular definition was wrong, and that was affected by the denominator. So a definition like this, f of x, y, comma, z plus what? H3. So this is increment in what? Z. So it means that you have to divide by what? H3. But in this case, it was divided by what? H2, which is wrong. So we have this minus the original function divided by, instead of dividing by H3, they divided by what? H2. So this makes this definition wrong. So what I want you to know is that if you have fy, increment in y, then the definition should be what? H2. If you have fz, increment in z, then the definition should be what? H3. But in this case, the increment is what? Z, right? And they divided by what? H2, which is what? Wrong. That is question number 15 and question number 16. Give me some short break. I'll be back with question number 17. Welcome back from the short break. I believe that you have been able to go through problem number 15 and problem number 16 and you are satisfied. Now, question number 17, you want to find the first partials of g of x, y, and z given this function xz over what? Y plus z at 1, 1, 1. Very interesting. Very interesting. It's going to be very easy, very, very easy. So once you see this, a rational function, and you want to find the derivative, then quickly what has to come in your mind is the quotient rule. If you don't want to use the product rule by changing this to a linear function, then you have to use the quotient rule, and you know how to use the quotient rule. You're not going to go through that lengthy process. You are going to use the fast approach. So first of all, g of x, y, and z equals xz over y plus what? Z. Okay? Now, we want to find the first partials of all these variables. So first of all, gx will be equal to, we are differentiating this with respect to what? X. So respect to x means that we have z at the top, then we maintain y plus what? Z, minus we maintain xz divided by what? Derivative of this with respect to what? X, right? And respect to x means that we are going to have 0 here divided by the square of the denominator. Now, we have to simplify this. We have xz plus what? Z squared. This will give us 0 divided by y plus what? Z all squared. Now, at the point 1, 1, 1, then our gs of 1, 1, 1 will be equal to 1 into 1 plus 1 squared divided by 1 plus 1 squared. And that is equal to 1 plus 1 divided by what? 2 squared. And that is equal to 2 over what? 4. And this is half, right? So we have the first part done, the gs, which is derivative of the function with respect to what? X. And so we had half for that. So we have half for that. So we have our gs of 1, gs of 1, 1, 1 to be equal to what? Half, right? Now, gy would be equal to, it means that gy means that we are differentiating this with respect to what? Y. So this, we are going to have 0 into what? The denominator minus, we maintain this, then we differentiate this with respect to what? Y. So we have 1 here, then y plus what? Z all squared. This we are going to have minus xz divided by what? Y plus what? Z all squared. And that we are going to have what? Minus 1 into 1 into what? 1 plus 1 squared. Then we have our gy of 1, 1, 1 to be equal to negative 1 over what? 2 squared. And that is negative 1 over what? 4. So that is for what? The gy. The last one, which is gz, will be equal to, we differentiate this, we have what? X, then we maintain y plus z minus, maintain sz, differentiate this with respect to z, we have what? 1 divided by y plus z all squared. So this we are going to have xy plus xz minus xz. So this cancels this, right? Divided by x plus y all squared. So our gz will be equal to only xy divided by x plus y squared. And that's equal to 1 into 1 divided by 1 plus 1 all squared. So we have 1 over what? 4. So the gz, we are also getting 1 over 4. So it means when we differentiated this function with respect to x, y, and z, we are having the result to be what? This is the result for gs, and when we evaluated, we had what? Half. Okay, and then this is the result for gy. Gy is this. When we evaluated, we have what? Minus 1 over 4. Then gz, we had this. When we evaluated, we had what? 1 over 4. So the answers are positive 1 over 2, negative 1 over 4, positive 1 over 4. And that is for respect to x, y, and z. So we are done with question number 17. Go on to question number 18. We asked to find the range and domain of this particular function. Remember, we have come across a function of this sort from our previous questions, right? So this one, the domain is going to be a minus x squared minus y squared, and this should be greater than or equal to 0. Remember, anytime you have an expression under the square root sign, it's either equal or greater than 0. Because if you have anything less than 0, you're going to have what? Complex, and we are not interested in that in calculus at the moment. So we have this, we change the sign, and then we are going to have x squared plus y squared to be less or equal to what? A. Right? So this is what we have. This is what we have as our domain. So the domain for this particular function is x squared plus y squared less or equal to what? A. Now let's look at the range. So range. So our range will have to lie within the function and the radius. So our range would have to lie within the function, this, and the radius, square root of what? A. So we can finally say that the domain of J, is it J? F. Let's use F as they use there. Domain of F is equal to x comma y belonging to R squared, such that x squared plus y squared is less than or equal to A, right? And then the range of J, okay, F, right? The range of F is f of x and y belonging to R less or equal to f of x and y less or equal to square root of what? A. So this is the range and this is the domain. Very, very simple. So as stated here, this is the range and this is the domain. And that is for question number 18. So this is question number 17. This is question number 18. Now let's give me some short break. I'll be back with question number 19 and possibly question number 20. Then we are down the line. I'll be right back. Okay, welcome back from the short break. This is the last part of the problem, and that is going to be question number 19 and possibly question number 20, and we are done for the day. With question number 19, basically we are using this definition to answer question 19 and question 20. So with question 19, we asked to evaluate the derivative of R respect to x and not respect to y. So first we start with what? Respect to what? X. Then we do that of respect to what? Y as well. So we state R is equal to square root of x squared plus what? Y squared. Right? So we know that this is the same as x squared plus y squared to the power what? Half. Okay, now we want the first derivative of this with respect to what? X. So the partials, dr, dx will be equal to, drop this, then you write the whole function again, then use the power rule to reduce the degree by what? 1. So you have -1 here, -1 on 2 here, then differentiate the inner function using implicit differentiation. Differentiate with respect to what? X, then you have what? 2x. So basically you have 2x divided by 2 into what? X squared plus what? Y squared to the power what? Half. So this we have x over what? S squared plus y squared to the power what? Half. So that is for what? Partial with respect to what? X from the problem given R. So this is the result. Now partial with respect to what? Partial of R with respect to what? Y. We are going to do the same work. We drop half, x squared plus y squared to the power minus half. Then this time we differentiate with respect to what? Y. So we have 2y. So we are going to have 2y divided by 2 into x squared plus y squared to the power half, and that will give us y over x squared plus y squared to the power what? Half. And this is what we have for that. And you know that this is the same as x over x squared plus y squared, square root of that. Okay, the same thing applies to y over square root of what? X squared plus y squared. Right, so that is the derivative with respect to x is this, and with respect to y is this. Now with question number 20, we are asked to evaluate the result that we have at the point 2 and 3. So this means that x is 2 and y is what? 3. So the x will be equal to, x here is 2 divided by square root of what? 2 squared plus what? 3 squared. And that will give us 2 over square root of what? 4 plus what? 9. So die x will give us 2 over square root of what? This will give us 13, right? So square root of what? 13. And then die y will give us 3 divided by square root of what? 2 squared plus 3 squared, and that will give us 3 over square root of 4 plus what? 9. So die y will give us 3 over square root of what? 13. So basically square root of what? 3 over 13. That's so that is for question number 20. So you know that this is the same as writing like rs is equal to 2 over square root of 13, and this is the same as writing ry is equal to 3 over square root of what? 13. So rs is 2 over square root of 13 and ri is what? 3 over square root of what? 13. Wow. Give it out for yourself for spending these whole hours on these problems. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and remember, our vision is very broad: to develop a world-class educational institute that integrates STEM and business programs into a unified environment for the modern student. So you know what? Share with your friends. Let the whole world know of us. And you know, we are employing tutors from the various expert fields. Actuarial Science is starting in no time. So Actuarial Science tutor is taking both probability and actuarial courses. You know, actuarial students are very expertise in probability stuffs. You know, they deal with risk, and also data analysis is in session. Economics is also taking effect from early January. Bye-bye.